Okay, so today during the class there was some problem with the recording, so I just thought that it will be quick. If I give a quick overview of whatever we have discussed, this might be good for your future reference. So I will just quickly go through whatever we have discussed in today's class. So we were talking about input and output statements in Python to start with. Input statements we have already discussed before. So as you have seen that we can introduce inputs to our codes by simply using a equal to sign, assigning numbers to different variables, giving inputs could be done in a single line also, like in a comma separated way like this. And moreover, you can also use input function, which actually asks for inputs to the user. So if you write a equal to input and just open close the bracket, you don't have to write anything. If you just open close the bracket, then it will the cursor will blink at the next point and the code will stop at that point, wait for you to enter some values to store as the variable a. Okay, so if you write something inside like this inside quotes, then that will be like a prompt message for the user to and that please enter some value for a or something like that. You can write there anything which will be prompting the user to give the input as to store it as a certain uh, value of a parameter or a variable. So next comes the output. So if I'm using Python 2, then output is just the print statement, printing on the screen. So if you write print x or y or whatever, these are the variable names. The value associated with this variable will be printed on the screen. If you write some statement inside quotes, then the statement will be printed intact. Whatever you will write, that will be printed. You can write that using single or double quote. So suppose I want to write x equal to 13, then you write x equal to within the quote and comma, then you write x, then only the value stored inside x will be printed if you are not giving any quotation marks. So it will write x equal to and then the value that is stored inside x. So if the value stored inside x is 13, it will print x is equal to 13. Okay, if you just write print x, it will just print 13. So there will be no x is equal to there. So this is kind of the idea of taking output. So I have already talked about single and double quotes. So they are like they could be used if you want to write some statement in your code. So triple quotes can also be used. So triple quotes will be like this, three quotation marks, and you can use that to insert some line breaks. So broken lines, like suppose I write here on and then give a enter and you write Python interpreter, then it will be printed as it is in screen if you write it with a triple quote. If you don't write it in a triple quote, if you use a single quote or a double quote, it will throw some error. So if you are using Python 3, then everything remains same except for you have to use brackets like this. So our collab runs in Python 3. You can see that on this on top of the screen. It is written. It is written in Python 3. So you use these brackets for your print statement. So about these broken lines and new lines, let me just elaborate a little bit more. So sometimes what happens is you when you give a output or print a lot of numbers together, if you don't apply a new line statement there, then everything becomes very messy and it becomes hard to see that what you are actually trying to print. So you either use a triple quote or you can use a single quote or a double quote with a slash n wherever you want to put enter or a new line. Okay, slash n stands for new line. So you use a slash n for introducing a new line. So if you write print, I write here on then slash n print Python interpreter, it will print a line with it with a line break. But if you just don't write slash n and put an enter between, then it will throw some error like this. So try out these examples. Okay, so just pause the video for a moment and go to your Colab and try entering these values. So just write a is equal to input and write enter value. And you will see that the value will be just value whatever you enter will be printed just exactly on right after this e. So that makes the entire thing a little bit messy. So you just put a slash n here. The cursor will wait after enter value in the next line here. So it will print enter value and then here the cursor will wait. Here it will take the input for the value whatever it is. Okay, so try it out in your Colab for a moment. So next, let us move on to types of variable. That is an interesting concept that we discussed today. So type is a system function that determines that what is the type of the particular entities that we are using. So suppose you write type and write an integer without any decimal places, it will show you, it will print int as its type is integer. If you print something with decimal points, if you just write 89.0, then it will show it as a float. Okay, you write a complex number, it will show it as a complex number. You write something like 2 to the power 80, so it will show you it's a long variable. Long variables are, as we discussed before, are really long variables where you have quite a long space to store them. So something like this. Okay, types are very important because sometimes while using Python as some calculation, arithmetic calculation, you have to take into mind, take into account of that particular thing that all the variables are not always of same type. So we don't have to worry about it much, but in some interpreters it happens that we when we're expecting some float results and we give inputs at integer, the result also becomes integer, right? So we will have an example like that. So here I have some inbuilt functions for this continuously switching between these types. So suppose you write float of 23, then it will convert 23 as 23.0. It will treat it. It will convert it into a float. If you write int and then you write some float, then it will cut off whatever is there after the decimal place. Note here that it is 0.58, that is more than 0.5, but still it does not consider, it does not round it off. It just considered the integer part of it. So this way you can convert complex numbers, real numbers to complex numbers. This way also you can write complex number. Complex 2 comma 3 means 2 plus 3j. Okay, so these are kind of some inbuilt functions with Python that comes with Python for swapping the types of the variables. So what I was talking about, that we have to remember the type of the variables, because in some interpreters what happens is that if you write something like this, say 5 plus 3 minus 9 by 4. So 9 by 4 is supposed to be a fraction. But all the numbers that we entered in this line are all integers. Okay, so Python will misinterpret this and might think that you are expecting an integer output only and give you an integer output instead. So that is something to be careful about. Okay, so in some it is a good practice to introduce a point zero to your integers to ensure that to ensure the possibility of opening up the possibility to have a float as output. So this is kind of a good practice to do that. So here I have also shown you some rounding off functions. So round off is kind of a little bit different from integers. Integers cuts off whatever after decimal places, but round off takes into account that if you are beyond 0.5, then it rounds up to the higher side. Okay, so if 23.9 you have, it rounds off to a 24. But if you have 23.9 here, the integer will give you 23 only. So some of you asked that how can we round it off up to a certain decimal place. This is the command for that. You put a comma and you write that how far you want to go beyond the decimal place. But the most important thing that I needed to discuss today is importing modules. Okay, so there are some toolboxes that comes with Python where you have some functions that are very essential, and they are devoted to a certain kind of operations, and they are assembled together inside a toolbox, and you can take it out if you want to use those functions. Suppose you are doing a mathematical calculation, you take out the math toolbox and use some specific mathematical functions like trigonometric functions or factorial or things like that. So how do we do that? How do we take out these toolboxes? Suppose the name of the module is math. Okay, so you write import space math, import space the name of the module that you want to import. So the module comes into your code, so you bring out the toolbox. Now to take a function out of it, you have to write math dot and the name of the function. So say square root. Square root sqrt is a mathematical function and it is inside the math module. So you have to write math dot sqrt and then inside bracket you have to write whatever the number square root you want to do. Okay, so in this way, sometimes you might think that okay, I have to write math dot square root this long thing, and can't I do it easily? Yes, you can do it easily like this. So what you can do is you can import math as some handy name, right? You can give a handy name like import math as m, and then you write m dot, and then you write the function sine of 2. Okay, m dot pi, m dot pw pow 2 comma 4. So pow is for power, 2 to the power 4, something like that. Pi is also is inside the math module, and it gives you the value of the pi. So this way you can use instead of math, you can just write simply m dot, and you can bring out the function. What you can also do is that you can extract functions from the module as well. So what you can do is you can actually take out functions, writing this that from math import, and you import the function only inside the program, right? So you write from math import sine and pi. So then you use sine pi by 4. You don't have to write m dot or math dot or anything. Okay, so you can do this as well. If you need lots of function from a particular toolbox, then you can write from math import star. So importing star means you extract all the available functions from that toolbox. Now you can use all of them freely. So this is kind of, you don't have to import pi and sine separately. You can use them in a form. So if you want to use them frequently, you can do that. If they are necessary in your code, you can do that as well. So here, this is a module that is going to be very handy for us, and we will need several functions from this module for our scientific computing. Let me just quickly introduce you to some of the very basic list of system function that comes inside the math module. So absolute is there, square root is there, factorial, you have to write the entire thing. Factorial is for calculating factorial of n. Then you have a ceiling and floor. These two functions actually gives you either the ceiling or floor of the value. So if you have 5.3, the ceiling means it will give you 6. So either 5 or 6. Okay, so if you have cost 5, then it will be 6 if you are choosing a ceiling function. On the other hand, a floor means the lower side of integer. It will give you the lower side integer. So exponential of x, for that calculating exponential, log and log 10 for natural log and log base 10. All the sine cos 10 for trigonometric, a sine, a cos, a tan for inverse, power x to the power y, and then you have comparison of two numbers, where if you write two numbers, you either get -1, 0, or 1, depending on it is less than, equal to, or greater than the other number. Okay, and mean and max are there for figuring out the smallest and the largest of arguments. So these are kind of some interesting functions that comes inside the math module. I urge you to try all these functions in your Colab, and think about small programs. Okay, small programs that you can execute only using these tools that you have. So for now, don't think about conditional codes like if else or loops. So leave them apart and think about some codes which you can write only using whatever you have here. Okay, so let us today I give you let me give you a small homework. So the homework is to find out the solution of a quadratic equation, and you know that it comes with b square minus 4ac. So you can use a module called Cmath. Cmath is complex mathematical operations, and that actually can perform all the functions that I have mentioned for complex numbers as well. So if you write like Cmath absolute of -1, it will write something like this. Okay, so you go ahead and try to write a code. So this is kind of a homework, so try it. Import the model Cmath, okay, and try to solve a quadratic equation. So you give the value of a, b, and c. So don't try to take input from the user. You write the them inside your code like ABC is equal to whatever the values you want it to be. You find the discriminator, which is b square minus 4ac, which decides either it is real or it is complex, and then you print the solution. So print the solution as the two solutions are this and this, something like that. Or you can put the first solution is this, the second solution is that. In this way also you can print. So write a small code based on this, and we will start our discussion from this point in the next class. Try it out and let me know if you could do it. Okay, so see you in the next class. Bye.